Hi everyone. All right, we're going to start our new unit, Unit 1 functions. So the first one we're going to talk about is Notes 1, composition of functions and operations. So we go down. So our goal is to simplify or solve equations, I shouldn't say simplify, by applying operations with functions. So what is a function? If you remember from Algebra 1, a function is essentially a set of inputs and outputs. Okay, so that one input goes with one output. Those are your XY coordinates. Okay, so the composition of two or more functions is a function within a function. So there's two ways that you can see this. You can either have your function inside, or you can have this lovely little notation, and it's read f of g of x. Okay, both of those. So f of g of x. So we're going to talk about how to solve those. So on the bottom here, given these functions f, g, and h, do the following composition. So basically whatever's on the innermost, you're going to complete first. So for A, we have h of 1 on the inside, and then f of whatever that is on the outside. So what that means is we're going to take our h function, h of 1, and we're going to plug in 1 wherever we see an x, and then simplify. So we have 2 minus 2, which happens to equal 0. So when you input 1, you get an output of 0. Now we're going to take that output and make it f of 0. We're going to plug it into x for the f of x function. So we've got 0 squared plus 6 times 0 minus 4. So then when we simplify, we should get negative 4. So when we have an input of 1 for h, we get an output of 0. When we have an input of 0 for f, we have an output of negative 4. So this would be our answer here. Okay. So if it was like C, where it's h of k of 3, you would do the k of 3 first. Okay, this goes first, and then whatever that result is, you're going to plug it into h. Okay, so k of 3, so we're looking at that piecewise function. So wherever we can use 3, sorry, and this is, there we go. We're going to plug it into that part of the piecewise. So it's going to be 4 minus 2 times 3, which equals negative 2. So we're going to take that number and then plug it into h, and h is the 2x minus 2x squared. So 2 times negative 2 minus 2 times negative 2 squared. So then negative 4, negative 2 squared is 4, times negative 2 is negative 8, so then we get negative 12. Okay, so whatever is inside the parentheses, that's what you plug in. Okay, so like for B, we have f of 1, and then whatever we get there, we're going to add 4 and plug it into k. All right, so I want you to try to do this one on your own. See if you can do that. You're going to do f of 1 first, and then you're going to add the 4 and then do k of whatever that is. So go ahead and do that now. All right, so when you plug in 1 for f, you get an output of 3. So then that output, we're then going to add 4 to it, and we should get negative 10 as our final answer. Okay, so even if you have something like E, where you have h of k of f, and that's all of 0, you're just going to do it in phases. So you would do f of 0 first, and then whatever the output is of that, you would plug it into k, and then whatever the output is of that, you'd plug it into h. So we've got f of 0 is our first step, k of the output is our second step, and h of that output is our third step. So I want you to go ahead and try that now. Okay, so when you plug in 0 for f of x, you get negative 4. and then that output becomes the input for k. And then for that one, you're using the middle line of your piecewise. So when you plug in -4 for the x value in function k, you get 5. And then you're going to take that 5 and plug it into h, and you should get -40. Okay, so that's composition of functions. So now I want to jump to operations with functions. So when you have addition, and it looks like this, f plus g of x, that means you can split it up into separate addition problems. Okay, you can do the function separately. When you have subtraction or a difference, f minus g of x, you can also separate it the same way. And then when you've got a product, so f times g of x, you just again have that separation that you can do and multiply them together. And then if you have a quotient, f over g of x, you can then just separate, put the first one of whatever's on top here is going to be on top when you separate, and whatever's on the bottom here will be in the denominator on that other part. So now the biggest piece to remember is that whatever's in the bottom cannot equal to 0. Okay? You can't have a 0 in the bottom, so the bottom can't equal 0. So we're going to do operations with functions. So we have these 3 functions. We're going to find each function. We're not going to worry about the domain for right now. Okay, so we can just cross that out for right now. So we're going to do a f plus g of 1. So we're going to take g of, what I would recommend you doing is you take f of 1 plus g of 1. So plug in 1 and then do your addition. So f of 1 squared plus 4 times 1, and then g of 1 is the square root of 1 plus 2. So in this first one we have 5, and in the second one we have root 3. So our addition, f of 1 plus g of 1, is equal to 5 plus root 3. Okay? So you're just going to follow that addition. So like b, we have f minus h and then of a plus 2. So whatever's on the inside of the parentheses, we plug in wherever x is. So f of a plus 2 minus h of a plus 2. So this can be a little long. So you're going to plug in a plus 2 wherever there's an x and f, and you're going to do the same thing with h. Okay, so go ahead and do that part on your own right now. Right, so there's my substitution. So you can see that we have a lot to do. So we have to expand and FOIL this first term, and then we've got a lot of distributing to do. So I'm going to do my little shortcut of my expand and FOIL. So I get a squared plus 4a plus 4 plus 4a plus 8. I'm distributing. And then here we should get 3a plus 6 minus 5. So really 3a plus 1. And then we have this negative out front. So minus 3a minus 1. And then we can simplify. So a squared, we have a 4a, and a negative 3a. So 8a minus 3a is 5a. And then we have 4 plus 8, which is 12, minus 1, which is 11. So this is our simplified answer. If we were to find the domain for this, let's say we were going to do that, this would just be all real numbers. And we're going to talk about that in one of our next note sections, okay? So same idea with C. We've got multiplication. So with multiplication, we have our 2 functions, and then whatever's on the inside, we're going to go ahead and multiply. So my f, there's a lot going on here. So I'm going to plug in my y minus 4 squared plus 4 times y minus 4, all in for my x values, multiplying 3 times y minus 4, and then minus 5. I'll put my bracket back there, sorry. So now I need to do all my normal simplifying that I would do, except I have a final multiplication I have to take care of. Okay, so I want you to go ahead and finish out the algebra for this problem. I want you to find your like terms, condense as much as you can, and then finish out your multiplication. So go ahead and do that now. All right, so I got 3y cubed minus 29y squared plus 68y. So hopefully you got the same thing. If not, we can talk about it. So the domain, if I was going to do this, would just, again, be all real numbers. And again, we will do that in another section. I just want to make sure you see, like, you can find your domain for each of these. So then we have one final one. We have the quotient h over f, and then it's just of x. So we're just plugging in x. We should just have 3x minus 5 over x squared plus 4x. So even if I factor the bottom, I'll move this up. So I have 3x minus 5 in the top. I can't factor that anymore. So even if I factor the bottom, I can't cancel anything. So what you started with is really your answer. Okay, and that's operations with functions. Whatever you're given, you plug in and then you simplify from there. Okay, so what I want you to do is I want you to go ahead and do this first practice problem. Okay, so given the functions f of x minus, equals x minus 4, g of x, and then you have plus f and g minus f and g multiplying and dividing. Try doing your domain, but it's not a big deal if you don't. I'm going to do it in there anyways, but I would try doing it since you're going to have to know it for future sections. So go ahead and do that now. So here's the answers that I got for your addition, subtraction, multiplication, and division. Actually, don't even worry about finding the domains. Okay, just leave this one alone. But this is what you should have for each of those operations. So hopefully you did all right with that. Okay, so this last one, this formula right here is going to be important for you. It's called the difference quotient, and we are going to talk about it in this note section, in this unit. You do need to know that for AP Calc, so we will talk about that in more in depth in a later section, but we can use function notation and composition of functions and operations with functions to actually do this without actually knowing what we're finding. So we have this function f of x, so 2 over 5 minus x. We're going to find f of a plus h, and then we're going to find this big mamma jamma right here. Okay, so f of a, you're just substituting a for x, so that's done. F of a plus h, same thing. So 2 over 5, and then you have minus a plus h. So if you simplify this further, you'd see that it's 5 minus a minus h, and that's what you get. So these two are really quick and easy. So now we're going on to the big guy. Okay, so we're going to take f of a plus h and subtract f of a. Okay, so we're going to take what we found, so 2, 5 minus a minus h, and subtract the 2 minus 5a, and then put it all over h. Okay, so this is why we were doing complex fractions, because you see what we have here. So our goal is we need to get these two fractions to be the same, or to be in one fraction, not the same, but to be in one fraction. So this goes back to that LCD that we talked about, lowest common denominator. So here it actually happens just to be each of them. So 5 minus a times 5 minus a minus h. So this first fraction is missing a 5 minus a, and the second fraction is missing the 5 minus a minus h. And then you should have both of those on the bottom, just like we talked about in our unit review. And you're still having this all over h. Okay. Distribute everything. Okay, so I'm going to move up here so I have more room. So 10 minus 2a minus 10 plus 2a plus 2h all over my binomial and trinomial in the bottom. Okay, still all over h. Okay, so you can see we have some things that cancel, which is kind of nice. Use different colors. So we have the 10 and minus 10 and negative 2a and 2a. So we're going to go ahead and cancel all those. And when doing that, we're just left with a 2h in top, and that's just fine. So at this point, what I'd want to do is do my keep, change, flip. So I'm going to keep my first fraction. So write my denominator, change my sign, flip my bottom fraction. So my h's cancel, so I'm left with 2, and then my 5 minus a times 5 minus a minus h. So this would be my answer. So when you're doing difference quotient, you're finding the slope of a secant or tangent line that goes through a curve. And this information will be helpful when you go to AP Calc. Okay, so if you have any questions, please let me know. Write anything down you want to talk about. But we're going to start using our class time to do practice problems. Okay, so more independent work to come. I hope you guys have a great day. Thanks.